objectives of this lesson are to first of all work with understanding function notation, and then to look at our graphs and how we can transform them. So let's first of all talk about function notation. We're going to use remember the two-column note format that we introduced. It's called Cornell Notes, where you have the topic on the left side and the details on the right. So if you're looking up something to review, always look in the topic column and then look for the information on the right-hand side. So let's first of all look at how we usually list things in algebra. For instance, an equation we might write is y equals 3x plus 2 would be an equation that we would write. And in function notation, we're going to introduce this idea of saying f of x equals 3x plus 2, where the right side of it is the rule, the algebraic rule that we're trying to use. Now, how this is helpful is we can use it for shorthand, because if we wanted to say, make the statement, find y when x equals 10, okay, that means put 10 in, you get 30 plus 2 will give you 32. Well, we can use the shorthand here of doing f of 10 equals, and that means immediately tells us put in 10 for x into the equation and then find out what the y is. So that gives us 3 times 10 plus the 2 gives us 32. So we'll use that f of x notation, and when you see it down in these graph problems, think of y equals. It means the same thing. All right, now what we're going to do is we're going to move the graphs, or we're going to transform the graphs. Let's first of all talk about using our graphs and do translations, side to side or up and down. Now our basic graphs, just as a reminder, if you have a linear equation where you have an equation like this, 3x plus 2, that equation is just a straight line. If we have instead a square on the equation, that's usually going to give us a parabola, which is going to be a U shape, either upwards or downwards. And if we have an absolute value with the linear equation, that gives us a V, either facing up or facing down. So let's talk about translations, moving the graph side to side. If we take and have this equation with an x minus 3 inside the square, notice that this is inside the parentheses and square it. That means inside means opposite. So what we have inside, this is going to be something that's going to be true for the entire year. All these new functions we're going to introduce during the course of this year, we're going to have, when we work with things on the inside, it's going to have the opposite effect of what you would expect. Now, a minus 3 then, on the inside with the x, we're going to move it to a positive 3. So we're going to go over here to positive 3. The shape of a squared equation is a parabola, so it's just going to be a parabola over here at a positive 3. Notice that this x plus 5, we want to go in the opposite direction, so we go out here to a negative 5 and draw the parabola there. So it moves it side to side, but you have to remember it goes in the opposite of what you would expect. A plus 5 goes to negative 5, a negative 3 goes to a positive 3. Now, if instead it's on the outside of the equation, like this plus 2 and this minus 1, that's going to move it up and down. So when you see this, it does go in the exact same direction. So with this plus 2, I'm going to go up to 2, and I'm going to draw my parabola going upwards. This is just a sketch now for it. So for my graph, it's just going to have a graph that is up at positive 2. Now this one over here, we're going to do both of them. The inside, now this is going to be a V. Remember, absolute value is going to be absolute value. It's going to give me a V graph, not a parabola. So when I look at this one, this plus 3 on the inside, I'm going to go over to negative 3 here. And then this -1, I'm going to go down to -1. And here's going to be where my v starts. I'll put the -3 up here. So my v is going to start here at the -1 for the y, that moves it up and down, but the opposite of the +3 there, and then draw my v from that spot. These are just sketches of it to show you how it moves. So the inside numbers move in the opposite direction, side to side. The outside numbers move in the same direction as you would expect. Let's talk about reflecting the graph. Now, reflection is over the x-axis means that we're going to take it and we're going to flip it over the x-axis. Flipped over the x-axis. In essence, what that means is we're going to take and do the mirror image. Right, so this graph, x squared, usually looks like a parabola facing up. I instead am going to flip it over the x-axis and sketch it as a parabola facing downwards. Same thing here, that negative in front flips it over, makes the absolute value flipped downwards, or the mirror image facing down. So since absolute value is a v, I'm going to do a v graph instead, going down. Now, next we're going to talk about stretching the graph. This means we're going to either stretch the graph upwards or downwards, or we're going to stretch it widthwise. We're going to make it wider or taller as part of it going up faster or going up slower. The number in front, if the number is an integer, then that number is going to make it go up faster. So if we had typically a graph that looked like this, where the graph would go like that, instead a 5 on it would make it go up a lot faster. This would make it go up and be narrow. If we have instead a fraction in front of it, that means it's going to stretch wider. This one, the 5 makes it go up faster because you're multiplying each y value by 5. It's going to be like grabbing it and stretching it up. This is going to be like grabbing it and stretching it wide instead. So 1/10 of the absolute value of x is a very wide v because it's going to make it go stretch wide. So in summary of these changes, these different numbers, what they do, the number in the very front that's being multiplied, that's going to be something that could either stretch it, either up or down, or it could flip it. So this thing here, if it's positive, it's going to stretch up or stretch wide. Whereas if we have a negative, it's going to flip it. Flip it over. So the numbers in front impact how if it's going up. So if you have a negative large number, it's also going to stretch it, but the negative will flip it over as well. This here, this number here, what it does on the inside is it goes with the opposite side to side. And what the number does out at the very end, being added or subtracted, what this does is it moves it up or down. So positive numbers would move it up, negative numbers would move it down. Let's look at an example that puts a lot of these ideas together. So first of all, when we look at this equation, I'm going to first of all do it by hand, and then we'll look at what happens if we look at a graphing calculator and how to see it. So first of all, doing this by hand, the -3 in front, the negative, remember, makes it flip over. The 3 in front makes it go steeper. So this graph is going to be steeper with the -3, but then also we look at these numbers here. The positive 20 is going to make it go over to a -20 here. And this positive 30 is going to make it start at this positive 30 up here. So a sketch of it, this is where the vertex would be right here at -20, 30, opposite the inside, same as the outside. And then that -3 is going to make the V, because it's an absolute value, go down, and it's going to make it go down steeply because of the 3. Okay, if it were a fraction, it'd make it go wider, and the other number stretches it down. So if we look at this, let's go ahead and look at domain of this and also the range. I'm going to lower this a little bit here. So the domain I'm going to put into interval notation as review. The domain for this, notice it has arrows that go in both directions. It's going down, but the arrows also imply that it's going wide. Down further, over further, because it keeps on getting wider here. So this domain goes from -infinity to infinity, because it keeps going in both the positive and negative direction. But the range, on the other hand, the highest point is 30. It never gets above it. So I'm going to go with -infinity as the low point, because it keeps going down, and we go to, up to 30, where it ends. We include the 30 because it actually gets to it, but we never include the infinity because we don't get to infinity. The min or the max, the min for this one is, there is no min, because notice that it goes down to -infinity, but there is a max. This value here, the max is equal to 30 on this, because it goes up to 30 and then goes down from there. Positive interval, where is this positive? Where is it decreasing? Okay, what we have to do is find out where it crosses the axis to know where it's positive. So what I want to do is I want to go ahead and look at my graphing calculator to help me do that. So on my graphing calculator, pull that up here. All right, over here on my graphing calculator, I'm going to put this equation in. Now I'm doing this, I'm gonna help you find where the absolute value is. You're gonna start graphing absolute value. So the new things that I'm gonna do for you here, I'm going to show you where absolute value is on the graphing calculator, but the review is I'm gonna show you how to change the window. So looking at this one, I'm gonna clear off what I had previously. I'm gonna clear off this equation. I'm gonna enter in -3. Remember, you have to use this opposite of 3. And now to find absolute value, what you do is you go to math, and then you go over to number. Notice you arrow over to that menu that says number, and the very first one says ABS, that stands for absolute value. So I'm going to hit enter, and it gives me an absolute value. So I'm going to put in the X, this is your X key, plus 20. And now I want to get out of the absolute value, because the next part of the equation is outside of it. So you're going to hit the side arrow here to get out of the absolute value. And then I'll put the plus 30. Okay? Now, my problem is when I hit graph here, I'm not going to see anything. I'm not going to see a lot. What I see is a little bit of a line here. I don't see the V that should show up on my graph. Well, the reason why is because this is way over at -20, this is up at 30. My window, so review of window, my window for this, remember, goes from -10 to 10. So I want to open up my window here and go over, maybe past -20, maybe I go to -40. Okay, so we'll go to -40 here. And then I'm going to change my X max, how far over in the positive X direction do I go? I'll leave it at 10, just so that I can see a big part of the window. How high up? It goes up to 30. Let's go down below the axis a little bit. So let's go down to the Y's here, arrow down to it. My negative, let's go ahead and keep it at -10. But let's go ahead and figure out what my maximum should be. Well, I want to get up at least to 30, so let's go a little bit above 30. Maybe we'll go up to 40. And now we'll see what the graph looks like. There's my V going downwards for it. What I want to know is where it crosses here, the x-axis. where are these 2 points? Because I want to know where it says the positive interval is. So looking back at my graphic calculator, so I'm going to look at finding that. I could estimate it. Well, let's use our table. Now to review what we're using the table, we had second table, and I'm going to look for when is the y value equal to 0. So I'm going to keep going up here until I get to 0. Oh, there at -10. It hits 0. Notice it comes back down. Come on over here. So my y value here will hit 0 again at -30. So it hits 0 at -10 and -30. So that's what I'm interested in, using my graphic calculator to help me figure that out. So the positive interval, when is it above the axis and positive here? It's at from -30 to -10. But remember, at -30 and -10, it's 0, it's not positive, so we don't include it on that, because it's either positive or negative on the axis. Now, when is it decreasing? Notice this is the section of the graph that it's decreasing. So if we start at -20 here and go in the positive direction, it's not increasing or decreasing at -20, so we'll use a parentheses. And then it goes off to infinity where it's decreasing, and infinity always has a parentheses on it. So here's an example of how we put together, for instance, using our transformations. Opposite on the inside moves it to -20. The 30 moves it up or down, moves it up to the same number, 30 here. That -3, the negative flips it over. The 3 makes it go steeply in that direction. And then we can figure out the mins, maxes, the positive intervals, and we can change our window to help us find out what these key values are. So we're looking at function notation. We've introduced this idea of f of x instead of y. That's to help us with some shorthand for functions. And then how we transform these graphs if we're given more information, how we move them up and down, side to side, stretch them, shrink them, or flip them.